Okay, welcome to the next video in the systems programming video series. We're going to continue with the assignment in week 2, moving to the final, part of the assignment, which is to implement this rock, paper, scissors program. We're going to go to the RPC source file. Okay, there's a little document on playing rock, paper, scissors. Um, we should have an AI and a human player each makes a choice and then wins a point based on the following rules. So rock beats scissors and so on with the usual rules. Making is just like usual. Running is just like usual. Prompt, user input. Which do you choose? User input. Uh, AI makes a choice. We update scores. If you make an invalid choice, then there's no change and so on. I guess let's see. When you make an invalid choice, but you said you wanted to play 6 rounds, does this count as a round? So that is 1, 2, 3, 4, 5, 6. So yes, even when you make an invalid choice, I guess that counts as a round. We should implement at least one function. Try to keep the program dry, which is to say don't repeat yourself. So, right, like abstracting repeated stuff into functions that are defined once and called repeatedly. We'll use the rand function from the standard lib library. We can encode rock, paper, scissors as 0, 1, 2. We'll use strcomp to compare player's choice against either rock, paper, scissors. Okay. Actually, yeah, okay. Um, and then your output should be similar to the above, and you can assume that the user enters an integer for the number of rounds. I guess maybe we need to check against it being a negative integer though. So, okay. I have an implementation. I'm actually, oh yeah, I did use strcomp. I was worried about that. But anyway, so I guess I'll just scan through this so that anybody who wants to see the implementation without having to wait for me to, build it and walk through it, you can see it here. But the rest of this video is going to be walking through the build. So since there's going to be I/O, then I know I need to include standard I/O. Okay, so we use the rand function, but I think the code that was distributed had this srand, which is to, I think, seed the random different. Oh no, not to seed. Uh, oh, it does seed, but it seeds with the current time so that it makes things truly random. I guess by default, the random behavior is seeded and therefore always produces the same result or something like that. That's my understanding. But okay, so this is to get truly random results. So let's actually leave that out until maybe the end. But okay, so but that will require us to import the time library, and randomness requires the standard library. So let's come over here and include the standard library.h. We will include time. And right, for processing user input and output and doing, right, using strcomp, as I think we know we will need to do, and so on. So string, in some sense, in the front end, the user is going to be inputting strings, which are rock, paper, scissors, and in the back end, the computer is going to be generating random numbers, 0, 1, 2, for the corresponding stuff. So it's probably, I often like to, whenever there is this translation that needs to happen between the two, then I like to write functions, right? And it says we need to define at least one function. So why not? Let's go ahead and write a function that turns a, maybe RPC to int, right? So this is going to receive a char star shoot, which, right, shoot is like what you say when you pick a rock, paper, or scissors. So, so shoot is just going to be something, some string that the user has input to play a round of rock, paper, scissors, right? So it should be either rock or paper or scissors. And I would like to take that and turn it into an int so that this can be compared to the AI's random choice of an int that codes rock or paper or scissors. So, okay. And so I fundamentally just want to say like if um, uh, stir comp of shoot compared with rock, if that is not zero, if that is not zero, then that means that we will enter, right? Okay, let's take it from the top. So stir comp shoot compared to rock, that will return zero if shoot is the same as rock, which is to say that we regard them as equivalent. So it returns zero if they're equivalent. Well, I want to say, if they are equal, so I want to write bang stir comp, right? So again, I feel like I'm making not so much sense in this explanation. So let's imagine that shoot is rock. If shoot is rock, then this comes out to zero. But then I want to enter the if block in this setting so that I can, basically uh, return the signal that shoot is rock, right? I would like to enter this if block in that scenario. But if it's returning zero, then what I need to do is flip it to a non-zero value so that we enter this if block. So I hope that was clear enough. But so if this basically, then I would like to return, right? So that is returning the code for the rock input, basically. Okay. If sort of going likewise, stir comp shoot paper, rock paper, yeah, that's next. Turn one, if stir comp shoot scissors, anything else. I get, and by the way, I guess I should remark that the return type of this function is int. Here I'm returning an int, here I'm returning an int, here I'm returning an int. All of that is great. But as far as the compiler knows, by the time I get down here to line 16, like in some sense, you and I know that, well, I don't know, okay. What I was going to say is you might be tempted to just leave it at that, right? Done writing the function. But what the point I wanted to make is, well, but the compiler doesn't even know that one of the earlier lines is going to, uh, determine the return value. And so we have to put an integer here. And that is true. We do have to put an integer here. I guess possibly a more important insight here is the user might have input an invalid input. We even saw that in one of the examples. So for one reason or another, we cannot leave the function as it is. We must code something for anything other than rock or paper or scissors, which is supposed to encode an invalid input. And so to code an invalid input, we're going to return, let's say, any integer other than 0, 1, 2. I could have made it 3. I could have made it a lot of other choices, but I'm just going to arbitrarily choose -1 as the code for an invalid input. Okay, so that is taking a string representing rock or paper or scissors and turning it into an int. There may be cause for going the other way around as well. So let's design a char star, taking us from int to RPC. So int x. And this is more straightforward. Well, I don't know, maybe. Anyway, if x is now here, it's probably worth sort of making the point that I was going to make earlier, which is at this point, you might not think that you need this return quote marks or anything that, especially on the back end, like we are going to be much more in control of the back end directly with our code. So we'll just make sure that any integer value is always the code of either rock or paper or scissors, right? You might be thinking something like that. And then you don't need to worry about any other integer. And so why would we need this line right here? Well, in any case, right, whether that line of logic makes sense to you or not, one way or another, we have to make sure that outside of these if conditions, we return some string because, again, the idea is that the compiler knows that this function must return a char, and the compiler does not know that these if conditions, that like one of these if conditions must occur. So even if you and I know that, the compiler doesn't know that. And so the compiler is going to be worried, especially at this line right here, did you actually return what you promised you would return, which is a string? So if you need this line returning a string to satisfy the compiler to know that this function returns a string. So that is the explanation for this line. Hopefully that makes sense. Okay, so we now have the ability to convert back and forth between string, rock, paper, scissors, inputs, and integers. So at this point, I think we're ready to jump into the main function. So int main, and I guess we want to find out what is the first thing we're supposed to do. And I guess it's to print this welcome message together with a prompt for a number of rounds. So let's go ahead and I guess first actually declare char star rounds. And that is, and I don't want that to be char star because I want that to be an integer. So let's say int equals. Now I'll say printf, control the line break in like that, close quote and close paren and that, and then, never called it, right, because what I really want to do is initialize it, and then scanf %d and rounds. Okay, so I have collected from the user a number of rounds, and I guess at this point, right, so if even invalid, inputs are supposed to basically play around, now in that round, nothing actually happens, but I guess what we could do is just immediately sort of go into a for loop using the number of rounds. Maybe we should check that the number of rounds is yeah, I guess non-negative at the very least. So let's say if rounds less than 0, so this would say, right, if you input an invalid number of rounds, right, a number of rounds that is negative, then you cannot have a negative number of rounds. And we return 0, meaning basically exit the program. Exiting with success, which maybe is debatable, but seems fine to me. So, but yeah, so having done that, it looks like we can just go ahead and jump into a for loop. So for int I, yeah, sure, equal to 0, I less than rounds, I plus plus. And so within each round, it looks like we want to prompt the user for an input. And here I'm going to just lazily use scanf to collect that input. And of course, I need to allocate, and so I should probably do that up here. I need to allocate space for a string answer. So I guess I'm going to call this char star RPC. Maybe I'll say player RPC. And I want to malloc that a certain amount of space. So let's say size of char times. So what? If scissors is less than 10 letters, why bother counting it out? So, and that's a 10, but that gives space for 9 letters, but okay, fine. 1, 2, 3, 4, 5, 6, 7, 8. So yes, all I need is 8 letters, but I have space for 9, basically, and then followed by the null character. So anyway, so we scanf, putting the user's string input into player RPC. Let's go ahead and also have an int player int, and that will be RPC to int, the function that we wrote just a few minutes ago, applied to player RPC. So that is effectively getting the player's choice. I suppose let's look at the play. So, if you enter that, the AI still makes a choice. So let's go ahead and have the AI make a choice. So for the AI to make a choice, we're going to use rand. And so how does the rand function work? Well, we haven't really seen it. We haven't really talked about it or worked with it. So let's come over and search for crand function. Let's, I guess, look right here. It takes no arguments. And so how does it work, right? So you get this random value. It seems to be, if you look, so as I was typing this, you could see this little piece of information saying that it picks a random integer between 0 and rand max inclusive. What is rand max? Well, presumably it's just some very large value. And so the question is, how do we make sure that we pick a random value between, or a random integer 0, 1, or 2? So this looks like, just directly printing out various random values. So the random, right, it's a random integer between 0 and a number about, probably as big as you can hold in this many digits. So how do you, make sure that your value is within the range that you want, basically? And somewhat funny, it seems to just, take that random value and mod it by, whatever the upper bound roughly is for what you would like to see. This is not going to produce a uniformly random number because, some, depending on what this maximum value is and depending on what your mod value is, uh, that is, right, not all numbers, right? So some mod values are going to have more representations as something that could be returned by rand than others. You're not going to get a uniformly random variable, but it's going to be so close to uniformly random for especially small mod values that I think you're not really going to notice the difference. But anyway, so long story short, the point is that if we want a random value between 0 and 2, as we do, right, because we want 0, 1, 2, 0 is rock, 1 is paper, 2 is scissors, then we will mod by 3. So that's how to use it. Okay, so we're gonna go ahead and say that if these were the player values, then we'll also want to have an int AI int, and that we will put here and mod that by 3. If you think about how we've set things up, rock is 0, paper is 1, scissors is 2. Paper beats rock, right? Paper beats rock in the game of rock, paper, scissors. So, going from paper left to rock, it wins, right? The bigger number wins, right? But then going from scissors to paper, the bigger number wins. But going from scissors, which is 2, to rock, which is 0, there the smaller number wins. So how could we efficiently, elegantly program the rule for who gets the point? Oh, right. And by the way, I guess we should also program or make space for a player score initialized to 0, int AI score also initialized to 0. I would say a nice, elegant way, right? The sort of the pattern here is that if anything's code is immediately before the other thing's code, especially when you consider module, things mod 3. That's the losing condition, right? So because rock is one before paper, then rock loses to paper, right? Because paper is one before scissors, then paper loses to scissors. Because scissors is one before rock when all is taken mod 3, then scissors loses to rock. And so let's try to program that basic idea. So if AI int is the same as player int mod, oh, sorry, +1 mod 3, parens right there. So what this would basically mean is that the player is one behind the AI when thinking mod 3, and so the player is losing if this condition is correct. And so we'll go ahead and say, do I need to maybe before getting into the actual like scoring, I probably should tell the right, just print the choices. So let's do that first. What I'm going to print to the console is that the player chose, and then I'm going to give the players, input from there. And then I'm going to say that the AI chose this string. Now that string should be the AI int value translated to rock, paper, scissors. So that's where I'm going to use my int to RPC applied to AI int. So there I've displayed the choices. I guess, this over here like gives a slightly different formatted display when you enter an invalid choice. Maybe, just to simplify things, I'll just leave it like this, but then what I'll say is if. Now what I want it, right, so basically if the player gave an invalid choice, then it would show up here. This would be -1 based on this return value of -1 that we decided earlier. So let's go ahead and say here that if the player int is -1, then we'll go ahead and just skip the round and print a message about this. So printf player's input was invalid. And so I think I will just break, or not break, continue, meaning that the for loop will, right, the rest of the for loop will not execute. So by saying continue, what happens is that anything after this in the for loop does not occur. Rather, we simply go straight back up to the for loop and increment I and do this all over again. So since I am saying continue, then, but the way that this wants me to do things, it still wants me to print the scores even after an invalid input. So maybe I'll do that here. Printf. Okay, so that's that. Actually, maybe it's more elegant if I simply test for this, print that, don't do any of that, because the printing, I need to print this line in both cases. So maybe it's just better if I put everything else that could happen in an else block. That strikes me as the more elegant way to organize this. So that down here I would print f. I guess I should have copied that thing that I just wrote so that I could paste it, but oh well. Player score %d. Okay, so what have we decided so far? We've printed what the player and the AI chose. We've checked for invalid input and decided that if the input is invalid, then we'll just print this message. And in both cases, whether it is valid or invalid, at the very end of everything, we do this here. Okay, but if in the else case, right, then we do want to check for does somebody win or not, basically. And so this is saying that if the player is one behind the AI when considering things mod 3, then the player loses, the AI wins, and so we want to increment the score. Do we give like an explicit message? So no, we just say you chose this and AI chose that, and then we just update the scores and display the scores. So that's all that's really left. So here we're just going to increment the AI score. So AI score plus plus. Now, if it's the other way around, if player int is one behind the AI int, then we increment the player score. Probably, actually, looking at this sure looks and feels like duplication. So probably for good design, the whole assessment of whether, given an AI input and a player input, we should abstract the decision of who is the winner into some kind of a function. Since like that just seems like more work than it's worth. If I were taking this more seriously, I would probably abstract this somehow into a function. But I just don't feel like worrying about that right now. So we'll just leave it at that. So yeah, we increment the scores, right? And if neither of these occurs, then that must be because it was a tie, and then the scores do not change at all, which is exactly what we want to have happen. So we don't need to program anything for that, and we still print the scores. And so I feel like this might be. Oh, and certainly after the for loop is done. Oh, do we need to print some? Oh, yes, we do want to check and decide and print at the very end whether we have a winner. Honestly, do we want to think about shortcutting the play so that like what if you said that you're going to play 5 rounds and you've already won 3 rounds? Well, you must win the game, so we would like to like terminate the game early so that you don't have to play 2 rounds when you already know you've won. So we could program that in. Why not? Let's do it. So effectively, what that would mean is we want to check to see if the AI score, basically what you want to think is, well, from here, now that this round has basically been played, is it even theoretically possible that if the other player won every single remaining game, that they could possibly win or tie? And if the answer is no, then we should just break out of this, right? And do likewise vice versa for the player score. So but basically we want to say that if AI score is bigger than the player score uh, plus basically the remaining rounds. So we've just played this round, and so if we add rounds, which was the variable storing how many rounds we're going to play, and we subtract off I, because this is the ith round, but because we've already played one more round, then I think we also want to subtract off 1. So like, let's just think. If there were 5 rounds, the AI score was 3. So right, so we've played three of the rounds. So I guess what I would be equal to 2 in that case, right? Because there's round 0, round 1, round 2. So we've just finished, indexing from 0, round 2. So the AI score is 3, the player score is 0, and I is equal to 2. So what we would want to say is that rounds, which is 5 minus 2, gets you to 3. But the total possible number of further points you could get is not 3, it is 2 at this moment. So anyway, just running through, if that like, meandering calculation of, what this condition ought to be didn't make sense, you can try to sort of reason through it in your own way. But basically, this is the idea that that this rounds minus I minus one is at the end of a round, basically the most points that one side or the other could possibly get after this round. And so if you take the maximum points you could possibly accrue plus your current score, if that's still smaller than the AI score, you should break, right? Like there's no way to win, and so we should terminate the game early. And let's just go ahead and say, or this could be the other way around, right? So if player score is greater than AI score, plus rounds minus I minus 1. So if either of those occur, then let's break from the loop, meaning terminate the loop, right? The for loop is over. We're going to just end the game and come down and do what we generally do in at the end of the rounds. So what do we do at the end of the rounds? We're going to, I think, just decide who won and print that to the console. So if AI score is greater than player score, printf AI 1, else if player score greater than AI score, player 1, else tie, and terminate the program. Yeah, that looks good. So did we malloc anything that I now need to? Yes, I did. So I should free up anything that I malloced, which is just that one thing, player RPC, and then null the pointer. So let's say that I'm gonna free player RPC, and player RPC is null, and then return. And that's all I malloced. I didn't open files or any other things that I feel like that I ought to close, but we haven't really encountered that kind of stuff just yet. Looks okay. Let's see what happens. Because I did not use the time thing, then that probably means that we're not going to get even apparently random behavior. Like every time I run this, it should do exactly the same thing, if I'm understanding that correctly. So let's see what happens. So let's make the RPC, and let's play RPC. And how many rounds do I want to play? 5. Which do you choose? Rock. AI chose paper, paper beats rock, AI gets the point. Very good. Let's do rock. I beat the computer, that looks very good, exactly as it should look. What if I said none, then invalid answer, and oh, it doesn't display the scores. I must have did not correctly think through what would happen. Huh. Player int is -1, which it was in this case. Then the player's input, right, I print that the player's input was invalid, else all of this happens, and then we ought to print the player's scores. Maybe did I not like save that before compiling or something? Let's exit. So Control C exits the program. Let's build again. Let's run again. Let's say 5 rounds. Let's say none. Okay, I must not have saved my most recent version of the code or something. Yeah, okay, it must have been like playing the old version. Anyway, okay. So I guess that's fine. Might want an extra line break just for readability there. And do I want an extra line break somewhere else? Maybe at the initial welcome message. Maybe here, not that this really matters, but let's go ahead and do that. Don't especially care, but let's just play through this. Now, ooh, and then it says player's score is -1. Well, that how is that possible? Oh, right, because I put player int, not player score here. And player int should be player score. Well, that's enough changes to want to reboot. Okay, that looks good, right? So none, player's input was invalid. It still prints the scores and then continues to the next round. So then if I say rock, then paper beats rock and AI gains the point. What if I say, just to make sure that it can read all of the inputs and AI beats scissors and rock. And the AI got 3 points in a game of 5 rounds. It won. I couldn't possibly beat it after this point, which is great. So yeah, and I think right, even though I wasted 1 round with a none, I still think that was the right time for the game to decide that I couldn't possibly win because basically the AI had 3 points, I had 0 points, and there was 1 round left to go. Uh, but before this, the AI had 2 points and there were 2 rounds left to go, so I could have tied. So that's why it let me keep playing. And that means that everything seems like it is designed exactly correctly. So I think I call this a success. Is there anything else that I ought to do or think of? I guess let's come back over here. We could randomize it if we wanted to randomize it, and then they're submitting your work. So I think that's it.